Okay, good morning, guys. How are you?
Good morning.
How was your weekend?
Morning. Weekend was okay.
So this week on Wednesday, we will have our first quiz. And, I wanted to get your opinion on that. What do you think? Should you do it during class or you find time after class?
Is it a takeaway or?
It's not a takeaway, it's a quiz.
If it's a quiz, then it's after
During class.
During class. Yeah, so maybe I will prepare a 1 hour quiz so that we will have class for the first 40 minutes and then the next 1 hour we'll have the quiz. Is that okay?
Why can't we have the whole lesson as a quiz?
Oh, yes.
The whole class.
Yeah.
Yeah.
Yeah, then in that case, I think I have to. Okay, no problem. We'll do that. Do you have any questions from the previous classes before we start?
Will it be on lockdown or on the Blackboard?
I will give you the details tomorrow.
Okay.
Do you have any questions? Or shall we proceed? Hello?
We can proceed.
We can proceed. Okay, so last time we were looking at rational expressions, simplification, and we ended the class when I was trying to simplify this kind of expression. I remember it was something like that. And there were two, I told you there were two approaches in solving this kind of, this is called a compound fraction, because in the numerator there's a fraction, the denominator will have a fraction. So it's a compound fraction. There are two ways of approaching this. First of all, you can express the numerator and as a fraction in the single denominator. Do the same to the denominator and then proceed with the usual division. So the numerator will have an LCM y, then 1 goes into y times, plus y goes into y1, so 1 times x is x. Then numerator, we have an LCM y, so y into y1, 1 times x minus 1 into y1, so 1 times b is by. Okay. Then now proceed with the usual division. So we want to divide y plus x. We want to divide this by x minus b, right? And we said that the idea is to invert the second expression, then multiply. So you have y plus x divided by y times y divided by x minus by, and you obtain y plus x divided by x minus by. This was one way. The other approach is to multiply the whole expression by the LCM, okay, of both the numerator and the denominator. So the numerator we have y as the LCM, denominator also we have y as the LCM. So in this case, we multiply the whole expression, the numerator by y, also the numerator by y. So we will have 1 plus x divided by y, the whole expression multiplied by y, all this divided by x minus y minus b times y. So then y times 1 is just y plus y times x divided by y, that is just x. Divide this by y times x divided by y, that is x. minus b times y is by. So given any compound fraction, to simplify, you can proceed in either ways. Write the denominator and the numerator, both of them as fraction, and then proceed the usual division of rational expressions. Or you could find the LCM of the numerator and the denominator, and then use it to multiply both terms, and then you end up with your simplification. Now, the next area that we want to discuss in these rational expressions is rationalization and of the numerator and the denominator. Any question on this before we proceed?
Yes, could you go over it?
Over which part? The first method or the second method? Or do you want another example?
You just go over this one from the beginning.
Yeah, so we have this expression. It's a compound fraction because the numerator has a fraction, x divided by y. The denominator also has a fraction. This is what we call a compound fraction or a compound rational expression. There are two approaches to simplify this. Of course, to simplify this is to write it as a single fraction. That is what we mean by simplification of these rational expressions. And the first approach is to make sure the denominator is a fraction with a single denominator. So instead of having 1 plus x divided by y, we could simplify this and write the whole numerator as a fraction. Take the LCM of 1 and y is y, and then 1 divides y times, so y times 1, that gives you a y, and then y divides y once, so 1 times x gives you an x. So this numerator, we can write it, the entire numerator as a fraction, y plus x divided by y. We do the same to the denominator. The LCM is 1, so we put it under a common denominator, which is y, and then y divides y once, so 1 times x, that's x, 1 into y, that is y times, so y times b, that is by. And then after expressing the numerator and denominator as fractions, divide these rational expressions, proceed in the usual way, where we said you invert the dividend and then, or the divisor, you invert the divisor and then multiply. So I take y plus x divided by y times the inverse of this, the reciprocal, y divided by x minus by, and then this y is cancelled, then I have a single expression, y plus x divided by x minus by. On the other hand, we could also find the common LCM. So in the numerator, we have two denominators, 1 and y. In the denominator also, we have two denominators, y and 1. So the LCM of 1, y, and 1 is just y. Then I will use this LCM to scale each of the terms, the numerator and the denominator. So that is what I have done over here. Just open the brackets. So y times 1 is y, then y times x divided by y, that's just x. And then similarly in the numerator, y times x divided by y, that's just x. And then y times b is just yb. So that's what I have. Are we good?
Kindly
Yeah.
repeat the second format.
Sorry?
Kindly repeat the second method.
The second method. The second method, you find the LCM of all the denominators in the numerator and in the denominator. So in the numerator, here we have 1 as a denominator and y. And in the denominator, we have y and 1 as denominators. So we need to find the LCM of all these. In this case, I only have 1 and y. The LCM of 1 and y is just y. Because if you list the multiples of y, that is 1 and y. If you list the multiples of 1, 1. Okay? And of course, we can also have 1 times y gives you y. So this is the smallest common, this is the common multiple, y. Then I use this common multiple to scale each of these terms. So what we have done here is just to open the brackets. Y times 1 is y. And then x divided by y times y is x divided by x divided by y, that is x minus by. Maybe let me give another example where the denominators are different. That will help. So for example, you ask to simplify alpha divided by 6 plus x divided by y, all this divided by x over 3 plus maybe 1 divided by x. This will be a good example. So we want to simplify this expression by this second approach, where we find the LCM of all the denominators in the numerator and the denominator. So we have 6, y, 3, and x. I've just picked the denominators. So in this, we have this 6, 3, and x. Then I find the LCM of these guys. Because 2 divides 6 does not divide 3. 3 divides 3 divides 3. X divides x, y divides y. So the LCM will be this product, 2 times 3 times x times y. In this case, 6x, y. That is the least common multiple for all my denominators. So what I need to do is to scale each of the terms with this or by this LCM. So what we will have, here is alpha divided by 6 plus x divided by y. The whole expression multiplied by 6xy. All this divided by x divided by 3 plus reciprocal of x. All this multiplied by 6xy. This is just the usual multiplication. So open the brackets. So first we have alpha divided by 6 times 6xy plus x divided by y times 6xy. All of this divided by x divided by 3. Now open the bracket denominator times 6xy plus 1 divided by x times 6xy. So,
Sorry, sir. I don't know if it's only by my side, but it's a bit blurry.
sorry?
I don't know if it's only in my side, but I can't see anything. But I can't see anything. It's a bit blurry.
Me too.
The whole board is blurred. Hello?
Half of it.
Especially on the left.
The left side.
Especially on the left, it's quite blurry.
Now it's worse.
How about now?
Better for me.
Shall we proceed?
Yes.
So we're just doing multiplication. 6 and 6 are common, so we can cancel. So we have alpha xy plus y and y, and then we have 6x squared. All this divided by, so 3 will divide 6 twice. X times x is x squared. So we have 2x squared y plus x divides x, so we have 6y. And then you can simplify if you want by factor. You have an x into alpha y plus 6x divided by, here y is common, so y into 2x squared plus 6. And if you use the other approach, you should arrive at the same answer. Is that okay now?
Yes.
Good. Let us now proceed to rationalization.
Will you give us time to copy the assignment? Let us write the example.
The what?
Excuse me, sir.
Yes, go ahead.
Never mind, never mind. You already rubbed it. I was to say that 2 was also common at the denominator.
Oh. Yeah, sorry about that. But if it's common, you can just factor it out. Rationalization. So to rationalize simply means to make an expression rational. We have done rational numbers. So these are numbers which can be expressed as fractions. And when you express them as decimals, they terminate. They're not like pi or an Aperian base on the roots of prime numbers. So let us start with the rationalization of numerator. Rationalization of the numerator. So this means this involves making the numerator rational, as simple as that. So for example, if I give you the expression a plus b square root of c, where this is a number which cannot be expressed as a terminating decimal. It's a non-terminating decimal and there's no pattern like pi. This is an example of an irrational expression. And we can make it rational by multiplying by what we call conjugate radical. So given any expression a plus b root c, then a minus b root c is called conjugate radical. Conjugate radical conjugate, no problem. Of a plus b root c. The reason for that is if you multiply a plus b root c by a minus b root c, you get a rational expression. So for example, a plus b c, you want to multiply this by a minus b root c. We had done difference of squares last time. So for example, call k b root c, then this becomes a plus k times a minus k. So this is a product of a sum and a difference, becomes a difference of squares. You will have a squared minus k squared. But k is b root c. What will k squared be? So from here, k squared is b squared c. And therefore you will have a squared minus b squared c, which is now rational because we have done away with this radical symbol. Okay, so this is the trick that you will use to rationalize the numerator or the denominator. So if you're asked to rationalize a numerator, just multiply both the numerator and the denominator by this conjugate radical, and it simply involves changing the sign here. So example, rationalize the numerator. So I give you square root of 2 plus h minus p. Rationalize the numerator. Maybe this divided by some C. Rationalize the numerator. So this is a fraction in which the numerator has a radical. So it's this is the irrational part. We want to make it rational. The procedure is to multiply both the numerator and the denominator by the conjugate radical of this. So in this case, the conjugate radical, I said you just change the sign. So this will be square root of 2 plus h plus p. So we want to multiply both the numerator and denominator by this conjugate radical. We'll have square root of 2 plus h minus p, all these times square root of 2 plus h.
Isn't it 2 minus h?
Plus p. This is 2 plus h.
Or in the question it's just okay. So no, I mean the conjugate radical. Wouldn't it be 2 minus h?
No, we change the sign outside. The sign outside the root.
You don't change the sign inside?
We change the sign inside. What I gave you here is a plus b root c, and I took.
Yeah, and then it becomes a minus b. Yeah.
Yes.
So here, why is it still 2 plus h?
Yes, it's 2 plus h, yes, but I've changed this to plus p. You don't change the sign inside the root. Okay? You change the sign outside the root. So this divided by c times root of 2 plus h plus p. So in the numerator, what do we have? We'll have 2 plus h minus p squared divided by c times square root of 2 plus h plus p. That is your final expression.
Can you please take us step by step on that multiplication?
The last step.
No, step by step on the multiplication of root 2 plus h minus p root times. Yeah, you just wrote the answer.
Yes, okay, I will do that. I use a difference of squares. So let me do it step by step, then I show you the trick so that you don't have to labor all this. So we are having square root of 2 plus h multiplied by square root of 2 plus h plus p. So I've taken the first expression, use it to multiply the second. Then I take the second term, use it to multiply. So minus p into square root 2 plus h plus p. Square root of 2 plus h times square root of 2 plus h. What would that be?
2 plus h.
That is 2 plus h. And then square root of 2 plus h times p.
Teacher, how did you group them?
How did I group them?
Yeah, up here.
I did not group. I'm just doing a multiplication.
Okay, so how are you multiplying?
Just expanding. So I take the first term here is square root of 2 plus h. Okay? Then I use this first term to multiply everything in the second bracket. So that's why I have square root of 2 plus h times square root of 2 plus h plus p, which is the second bracket. Then I take the second term minus p, then I use it to multiply everything in the second bracket.
Okay.
This is how we do expansion. We have done this before, I think. So the first term is root 2 plus h times root 2 plus h gives you 2 plus h. Then now take square root of 2 plus h multiplied by p. That gives you p times square root plus h. Okay. So we are done with the first part. Second part, so we have minus p times square root of 2 plus h, and then minus p times p, that is minus p squared. Okay? What can you say about these terms in the middle?
They cancel out
Why?
They are
because they're the same number in positive and
like
negative.
terms.
They're identical.
They are not,
They
well,
are like terms.
no, not identical, not like terms. They are additive inverses of each other. So when you combine two additive inverses, you get the additive identity, which is 0 in this case, because we are in the vector space of the real line whose identity is 0. So you simply remain with 2 plus h minus b squared. Okay. And this step can at times get very messy. So I advise you to always remember to use a difference of squares to simplify such expressions. You don't have to go through all this because this middle term will always collapse. So the only expression you need to remember is that a minus b multiplied by a plus b is a squared minus b squared. We proved this. We proved this in the earlier parts of the course. So in this case, take a to be root 2 plus h, and take b to be p. Well, the answer should be a squared minus b squared. So what is a squared? A squared is just going to be square root of 2 plus h squared. That gives you 2 plus h. B squared is going to be p squared. So you expect a squared, which is 2 plus h minus b squared, which is a squared. You get the same answer without having to. Because when you expand, you might even make some mistakes. Okay. So I advise you to use this identity. This is called the difference of squares. It will help you with this whole rationalization. So to rationalize a numerator, first step is to find the conjugate radical of the numerator and then multiply both the numerator and the denominator by the same conjugate radical. So this does not change the expression because it's like we are multiplying by 1 because we are multiplying and dividing by the same term at the same time. So it's like just multiplying the whole expression by 1. It does not change the meaning of the expression. Any question?
What about the downer part?
The downer part, we are not interested. We just want to rationalize the numerator. So as long as the numerator is rational, oh, sorry about that. So here should be
So the C remains okay.
2 plus h plus p. Sorry about that. Sorry about that. We are only interested in making the numerator rational. So we don't care what happens down here. That is if we are rationalizing the numerator. Okay. Questions?
Sir, I'm confused.
Where?
From the 2 plus h plus p squared. Square root 2 plus h.
Here?
Above. Yes.
Yes, this is 0 because you have p plus p times root 2 plus h minus p times root 2 plus h. It's like 2
I
minus.
know, I mean, this 2 plus h plus p. I don't know. Yes. No, the one on top.
This one?
Yes.
You don't know why
I'm confused on the whole line.
where it came from.
Yes.
Yeah, this came from square root of 2 plus h times square root of 2 plus h.
Yeah.
You're multiplying. You know how to multiply expressions. Just opening the bracket. You take the term outside the bracket and use it to multiply everything inside the bracket. So the meaning of this is square root of 2 plus h times square root of 2 plus h, and then plus square root of 2 plus h times p, and then minus p times square root of 2 plus h minus p squared. So here, root 2 plus h times root 2 plus h is like taking a square root of a number and multiplying it by itself. For example, square root of 4 is 2. So square root of 4 times square root of 4 is 2 times 2. You get the number. So here we just get what is inside the root symbol, which is 2 plus h. And then plus square root of 2 plus h times p minus p square root of h minus p squared. We are dealing with real numbers and we know multiplication is commutative. So changing the order of the terms does not change. So root 2 plus p, root 2 plus h times p is the same as p times root 2 plus h. So they are actually additive inverses. So this term 0, we went up to 2 plus h minus p squared. That was the numerator, and then the denominator remains the way it is. Square root of 2 plus h plus p. So our goal was to make sure that numerator has no radical symbol, but the numerator is rational. We have achieved that. Is this better now?
Yeah, excuse me, sir.
Go ahead.
Your board, your screen is very little. I'm not seeing the writings on the board. Could you make it bigger? Yeah, it's better.
My writing?
No, not your writing. Your computer screen was small. It was on minimum. I was not seeing the lesson on the board. But it's better like this. I'm seeing it now.
It's okay now. Okay.
Yeah.
So you have to multiply both numerator and denominator with the conjugate radical.
Yes.
Every time. Okay.
The reason for that is so that you do not change the meaning of the expression.
Okay.
No, this is like multiplying by 1 because I multiply by this term and then I divide by itself. Remember, they're the same. You can just cancel them out and get 1. Go back to the original expression. So whether you're rationalizing numerator or denominator, multiply both terms by the conjugate radical.
So, excuse me, sir.
Go ahead.
So where you have written a squared minus b squared, and the b is negative p. You've written p. I don't understand.
You don't understand?
Yeah, because you've written p and it's supposed to be negative p from the original equation.
Do you remember this term that we derived, this difference of squares?
I remember.
You remember it? I am just trying to make this expression look like this identity. Because we proved it, so it's an identity, we can use it. So where you have a minus b, I have here root 2 plus h minus p. And then I have a plus p, I have root 2 plus h plus p. So this becomes my a, this is my b. This is my a, this is my b.
Yes, so as you can see, your b is negative p. You have written p.
My b is positive p, it's positive.
But from the question, okay then.
From which question?
Yeah, from down here where you written before you wrote the conjugate radical. It's 2 plus h minus p.
Yes, the conjugate radical is root 2 plus h plus p. This is plus. The conjugate radical of an expression is simply an expression which multiplies that particular expression and makes it rational. It does away with the radical symbol. In this case, it removes the square root symbol. And as you can see, there is no square root symbol now in the numerator. Did I confuse someone? Hello? Did I confuse you guys?
No, sir.
No.
Let's do an example on denominator. The procedure is the same. Rationalize the denominator. So we'll have 1 divided by square root of, I don't know, 2 plus 1. Yes. So in this case, we have an irrational number in the denominator, which is root 2. We want to make sure this denominator has no irrational term in it. So we want to get rid of this root symbol in the denominator. So
can you open your screen? I'm not seeing the board.
Sir, I think you should write it on the other side, because that side is a little bit blurry.
Okay, the board. Does it look better?
Yes.
So what will be the conjugate radical of this denominator?
Square root of 2 minus 1.
Say square root of 2 minus 1. So we will multiply the numerator and the denominator by that. Okay. So we have 1 divided by square root of 2 plus 1 multiplied by square root of 2 minus 1 divided by square root of 2 minus 1. Okay. So the first step is to identify the conjugate radical. And then we use that conjugate radical to multiply both the numerator and the denominator. So that is what I've done in the second step. Okay. So now here we have 1 times square root of 2, that is square root of 2. 1 times 1 is just 1. Divided by, what do we have in the denominator?
2 plus 1, 3. 3.
Are you sure?
No, it's giving 1 at the end.
1, yeah.
Yeah.
2 minus 1.
So when you use the identity difference of squares, a squared will be 2, b squared will be 1. So you end up with square root of 2 minus 1. That's your final answer. Okay. We have made the denominator rational because now in this case the denominator is just 1, which is a rational term. Suppose someone used, here we have used 1 minus root 2 minus 1. Suppose someone used 1 minus root 2. Would they still arrive at the same answer? So let us see, take 1 times 1 minus root 2 divided by root 2 plus 1 times 1 minus root 2. The numerator, it's easy. We just have 1 minus root 2. What do we have in the denominator? Addition is commutative, so I can write root 2 plus 1 as 1 plus root 2, and then times 1 minus root 2, where in this step I've not done anything, I've just changed them because I know addition, the order does not matter. So whether I start with root 2 or I start with 1, I should get the same answer. Then now this looks like a difference of squares. So we'll get 1 minus root 2, 1 minus root 2, divided by 1 squared, that is 1, root 2 squared is 2. So we get 1 minus root 2 divided by -1, which is 1 minus 2. And then finally you'll have -1 plus root 2, which should be the same as root 2 minus 1. Is that okay?
Is this an alternative?
It's not an alternative. I just asked, what if someone used a negative of this?
What do you mean a negative of that?
What I mean a negative of that. So what we have here is root 2 minus 1. Huh? Okay. Then take -1 into root 2 minus 1. -1 times root 2 is negative root 2. -1 times 1 is plus 1, which is 1 minus root 2. This is what I have here. So the point I wanted to drive home is that the conjugate radical or its additive inverse will always work. You might use radical or use its additive inverse.
Excuse me, sir. In the first example, how did you arrive at the answer as root 2 minus 1? I can see we have root 2 minus 1 over 2 minus 1.
Mm-hmm. What is 2 minus 1?
How? Yeah, over 2 minus 1 is 1. All right. Okay, thanks.
Okay. More questions?
Excuse me, sir. Can you try and use the formula that you've shown us in the previous question of
yes,
A minus B? A minus B.
Sorry?
You said that you can use an alternative method, which is much shorter, where you apply the rule of A minus B, A plus multiplied by A.
That's exactly what I've done here.
Mm-hmm.
Here, this is a difference of square. This is A, this is B. So then I just came to the numerator is okay. The numerator I have A squared is 2. Square root of 2 squared is 2. And then 1 squared is just 1.
So you're going to work with the negative, not the positive.
This side. This side is okay still. I take A to be 1, take B to be 2. And then I will have A squared. So 1 squared is 1. Root 2 squared is 2. So I have 1 minus root 2 divided by 1 minus 2. 1 minus 2 is -1. Then, so 1 minus root 2 divided by -1. I divide each time by -1. 1 divided by -1 is -1. Negative root 2 divided by -1 is positive root 2. So I'm getting the same answer.
Oh, thank you. I've seen it.
In all these cases, I'm using the difference of squares. Okay. You see, most of these mathematical identities, once you have proved it and you are sure, you're allowed to use it anywhere. You don't have to go through the pain of multiplying everything, grouping terms, because you can make mistakes. So it's better you use an identity which is known. Any more questions? Great. Let me give you guys an exercise. Rationalize the numerator. Square root of j plus k minus t divided by p. How will you go about this?
You find the conjugate radical, which is square root of j plus k plus t.
Conjugate radical, square root of j plus k plus t, and then
you multiply it in the both numerator and denominator.
so you take the numerator j plus k minus t, multiply that by j plus k plus t divided by p j k plus t. Then here you can spot a difference of squares, right? So multiplying a difference by a sum. So this is a difference of squares. So you take square root of j plus k as your a and t as your b. And what do we have in the numerator?
J plus k minus t
J plus k minus t squared.
Good. J plus k minus t squared. And the denominator stays the way it is. Okay. So we have done a rational
Mr. I have a question. When you are conjugating the radical, in this example, can you also use like instead of j plus k plus t, can you use like j minus k minus t? Can it still work?
No, the other thing that can work is you can use minus square root of j plus k minus t. This will
So
work.
like how do you know which sign to pick?
There is no problem. Any sign will work because I told you they are additive inverses of each other.
Excuse me. Hello, excuse me.
Go ahead.
I can see the answer at the bottom of the board.
Here.
Yes.
This is just j plus k minus t squared divided by p square root of j plus k plus t. Let me make one final remark. There's someone who is asking about conjugate radical use. How do you know, or what do you use? So suppose I give you a plus b to c. How do you get a conjugate radical? Change any of these signs. So remember, this is plus a plus b. Change any of the signs. So you can use either minus a plus b root c, or you use a minus b root c. Change any of the signs, whether it's either the one in the middle or the one at the end. Change the sign of any of the terms, then you have your conjugate radical. Any of these will work. They are additive inverses. If you add the two, it gives you a zero. So any of them will work. Is that clear? So if you are rationalizing any expression, whether it is numerator or denominator, the conjugate radical of this will be either you change the sign of the first guy. So this, instead of plus a, we have minus a plus b root c, or change the sign of the second guy. Instead of plus b, you have minus b, a minus b root c. Is that okay?
Yes.
Any of these will work. You can show that. It's not a big deal. Let's look at linear equations in case there are no more questions. Linear equations. Linear equations. In one unknown. So equations are expressions equations are statements. Let me use the first statements. Two expressions are equal. And equations are very ubiquitous in science and its applications. For example, we have, for those of you who have studied physics, there are the equations of motion, equations for energy, equations that govern the flow of a fluid, or equations that govern the stock exchange in the market. They're simply expression, a statement that two expressions are equal. And we normally use the equal sign. So for example, you can say that 2 times 2 is equal to 4. So 2 times 2 is the first expression, 4 is the second expression. Use that equal symbol to mean that the left-hand side and the right-hand side are one and the same things, or is the same item or identical. Now, in this class, we want to learn how to solve linear equations in one unknown, and the term linear is not new to you. Can someone remind us what's a linear expression? What is a linear expression? If you remember classification of polynomials, we had constant polynomials, linear polynomials, quadratic polynomials, cubic polynomials, quartic polynomials. Can someone infer a linear expression? What's a linear expression? Any volunteer? What does the term what do you mean by the term linear?
Straight.
Straight line.
Where the highest degree is 1.
Highest degree is 1. I suppose the person who said straight refers to the graph. Remember, these are functions, and there are 4 ways to represent functions. You can draw the graph, you can do it in statement form, you can draw a table of values, or you can give a formula. So there are 4 ways of representing functions. And when you draw the graph of a linear equation, you expect a straight line. So I hope that is what the person who says straight was referring to. Yeah, you're good. So this will be simply equations in which the unknown variable, the highest degree is 1. So the unknown variable has, the unknown variable could be x or could be y. So if the highest degree is 1, then we will have a linear expression. I need to define some few things. First of all, definition of a linear equation. A linear equation is any equation equivalent to the form ax plus b is 0. So this is a linear equation in x, where a and b are real numbers. X is the unknown. Any equation which is equivalent to this is called a linear equation. And what do you mean by equivalent? In mathematics, 2 equations are said to be equivalent are said to be equivalent if they have same solution set. So that means any expression which will have a similar solution set to this is called a linear equation. And we will refer to equations which have the same solution set as equivalent. I will give you an example of equivalent systems. And there are two ways to obtain equivalent expressions from any equation. And we need the following rules. Number one, adding the same term.
Excuse me, do you mind writing bigger letters? Because
Bigger than this? Okay, I'll try. Both sides gives an equivalent system. Is that better now?
that's better, thank you.
Okay.
Only raise the side yet.
So for example, let me give an example here. Suppose I give you an expression that A is equal to B. Then if you have the same term on both sides, you will get an equivalent system. For example, let's say I add K on both sides, then A plus K is equal to B plus K will be an equivalent system because they will have the same solution set. So what we are saying is that this equation, I call 1 and equation 2, are equivalent to mean that they have the same solution set. So if I solve the first equation, then the same solution set will be identical to the one for the second equation and vice versa. Secondly, multiply both sides an equation by the same non-zero term gives an equivalent system. Equivalent system. And the word non-zero is very important. So example, suppose you have P is equal to Q, then if you scale both sides by a non-zero constant, let's say K, then KP should be equal to KQ, where K must not be 0. And I will give you an example why K must not be equal to 0. At this point, I also need to state to you that not all equations will have solutions. There are so many equations which do not have solutions, and I will be giving you an example shortly. But before that, this idea of equivalence will help us to solve linear equations. You remember that adding a term on both sides gives an equivalent system. So suppose I have the second system, which is not easy to solve, then I just subtract the common term and have a simpler system. Then I will be sure that the solution to the first system will be the same as the solution to the second system. And also suppose that I have an equation in this form, Kp is Kq, where K is non-zero, then I could simplify this by dividing through by K. That's why we're saying K must not be 0, because division by 0 does not make sense, does not make much mathematical sense. It's not defined actually. So dividing this by K, you get a simpler system. Essentially, we'll be using these two rules to solve linear equations. Now, let me give you examples of linear equations and examples of equations that are not linear. example of linear equations. So an equation like 2y is equal to 6. This is an example of a linear equation. The unknown variable is y, and the degree is 1. So this is a linear equation. An expression like 2x plus 70 is equal to 90,000. It's a linear equation in x because the highest degree of x in this case is 1. So these are two examples of linear equations. Then let's look at examples of nonlinear equations. Examples of nonlinear equations. Nonlinear. So these are equations which are not linear. Nonlinear, not linear. So for example, and you will tell me why they're not linear. 2x plus 6x plus 70, 0. So you have A, B, C, D. I'm claiming that these are nonlinear equations. So let's see. The first equation, A. Why is it nonlinear?
The highest degree of x is not 1.
It's power to 2.
Yeah, so this is a quadratic equation, and later we will see how to solve quadratic equations. So this is not linear because the highest exponent is 2. For linear equations, the highest exponent must be 1. How about B? Why is B nonlinear?
It's nonlinear because the degree then x is a half.
Yes, we have a term that has a half as its degree. So this is not linear. Actually, if you draw the graph of the root symbol, it's the graph of the square root. It's not a straight line. It does something like that, and this is not linear. For linear equations, the graph will be linear. For example, this one, the graph will look like. So if I have this as x and I have this as y, the graph will look like that. That will be the graph of this equation. How about part C? Why is this nonlinear? Jay Wanjiku.
Yes,
Why is that equation nonlinear?
I'd say that the first one is a fraction. and it has the power of 2. So the exponent is 2 on the denominator, and it's a quadratic equation because there's three sections.
Well, you have an idea, but how you are putting it doesn't come out clearly. So there are so many reasons for this equation being nonlinear. First of all, the exponent here is -2. Remember, you can write this as 10x to the -2. So you have a negative exponent. Linear equations do not have negative exponent. And then here you have a reciprocal, 1/x, which is x to the -1. So first of all, this term is nonlinear. This term is also nonlinear. How about sine of x?
Sine ranges from infinity.
Well, sine of x ranges from -1 to 1. But if you draw the graph of sine x, you get a curve like that. It's also nonlinear. So I gave you an equation in which all terms are nonlinear. Sine of x is also nonlinear. This is the graph of sine x. You can plot this in. How many of you know how to use Python? Is there anyone who used Python before? Anyone ever used Python?
No, sir.
Yes.
Yeah, you can draw the graph of this. If you find time, you might try to do some of these things in Python so that you see how they go. So you can draw the graph of this sine in any interval. Choose any interval, maybe -10 to 10, and draw this graph in Python. You will need to import NumPy, and you also need to import matplotlib .pyplot. Then you can use, you will generate the first a linear space, and then after that you find the sine and then draw the graph in Python. It's very easy to do. How about part D? Part D. Is this linear or non-linear?
Non-linear.
Linear.
Non-linear.
Reason?
As we discussed in C, so cos and sine, even if it ranges from -1 to 1, the graph, both of them are that curves.
Yes, that's. So make sure you remember the definition of a linear equation, and make sure you are able to give an example of a linear equation. And you should also be able to solve a linear equation using the two rules we have given, that when you add the same term on both sides of the equation, you get an equivalent system, which means the solution to this new system is the same solution to the old system. And also that if you multiply both sides by the same non-zero term, the reason for multiplying with non-zero term is that we don't allow division by 0. Okay, so multiplying both sides by the same non-zero term also gives you an equivalent system, so that if you can solve this new system, if it is simpler, then you are sure that this solution is the same solution for the system that you started with. Examples. Solve the equation. So let's start with a simple thing. X plus 2 is equal to 0. How do you solve the equation x plus 2 is 0? Remember, we're using two rules. We need to add the same term on both sides or multiply both sides by a non-zero term. So in this case, let us add -2 to both sides. Add -2 to both sides. So we will have x plus 2 minus 2 is the same as 0 minus 2. What is 2 minus 2? Well, that's 0. So we have x plus 0 is -2. which simply means that x is equal to -2. And I have used the first rule where adding the same term to both sides gives an equivalent system. And the equivalent system I have in this case is that x plus 2 minus 2 is -2. The solution set to this new system is the same as the solution set to the system that I started with. So x is -2 solves both this system and that system. So the solution to this is x is -2.
What if you have x plus 2 is equals to 0, so you just take the plus 2 to the other side and it becomes negative?
Well, ideally that's what you are doing, but that's what we are doing actually. You're just taking this to the other side.
Also, doing that way is also okay.
It's actually the same thing. I mean, I know you were told that once a term crosses the equal symbol, it changes the sign. That is this comes from the rule that when you add the same term on both sides, you do not change the meaning of the equation, or you get an equivalent equation. It's the same thing, just that now we're doing everything from scratch, okay? But it's the same thing, you're right. You just take +2 to the other side, it becomes -2. I mean, we're just doing this thing from scratch, okay? So that was very easy. How about solve for x? Solve for x. In this case, alpha, beta are real numbers. So this is a case which will require us to use both the two rules at the same time. We will need to add similar term on both sides, and we will need to multiply both sides of the equation at some point by a non-zero term. So first, add negative alpha to both sides. Add negative alpha to both sides. So you have 3x plus alpha minus alpha is beta minus alpha. This gives you the system 3x is beta minus alpha. Okay. This is equivalent to what you are doing in high school. Just take positive alpha to the right hand side and the sign changes to negative. Then at this stage, we need to multiply both sides. Multiply both sides by a third. Because we said if you multiply both sides by the same non-zero term, the meaning of the expression does not change. You get an equivalent system. So this is a third, and 3x is the same as a third, and it's beta minus alpha. Finally, you have x is equal to beta minus alpha all. Any question? So this was a system that required you to apply both the rules, where you add the same term both sides and also multiply both sides by the same non-zero term. And it must be non-zero because you don't allow division by 0.
So can't you just say multiply both sides by 3?
Sorry?
Oh, can't you say divide? Okay, divide both sides by 3.
Yes, it's the same. Divide both sides by 3. It's the same. You're right. Any more questions?
Nope.
No questions. Too easy. How about equations involving fractions? Equations involving fractions. Solve for x, so I give you x divided by 6 plus x plus 2/3 equal to 1 divided by 2. So we need to solve for x, and we have fractions in our system. We have a 6, we have 2/3 and a half. First step, find the LCM for the denominators. So need LCM of 6, 3, and 2, which is 6, and then multiply each term by the LCM, in this case 6. So we will have x divided by 6 times 6 plus x divided by 1 times 6 plus 2 divided by 3 times 6 is equal to 1 divided by 2 times 6. We are multiplying each expression by the LCM. Remember, this is the same as applying the second rule, because we have multiplied the first, the left-hand side by 6, and also the right-hand side by 6. So what do you get? First, we get x plus, so 6 cancel 6, then 6x plus 2/3 times 6, so 3, 2, that's 4. Should give you 3. Then collect like terms. Collect like terms. So x plus 6x is 7x plus 4 gives you 3. You've just collected like terms, x and 6x, so combine them to 7x, and then add -4 to both sides. 7x plus 4 minus 4 is 3 minus 4. So that means 7x. So 4 minus 4 is 0, additive identity. Must be 3 minus 4, which is -1. And then the last step, multiply by 1/7. So 7x is 1/7 is -1 is 1/7, which means x is simply -1 divided by 7. Just like with factorization, you can always check for these linear equations if you have the right output or the right answer by substituting this your solution to the original system and see if the system is satisfied. Okay, so in this case, to check if the steps are right, I would put x is -7 in this expression and see if this equation is satisfied, which means if I put x on the left-hand side, I should get a half. That is what it means for the equation to be satisfied. Any questions?
No, sir.
Good. I said that equations, not all equations will have solutions. So let me give you an equation which does not have a solution. Before that, when someone solve for this, solve for x, j divided by 2 minus x plus 5 is 1. How would you proceed? Given this 3 divided by 2x plus 5 is equal to 1. Solve for x.
Sir, would it be you'd have to find the LCM of the denominator?
Yes, find the LCM of the denominators. The denominators are 2 minus x, there's 1 and a 1. LCM of 2 minus x, 1 and 1, which is just 2 minus x, because that is the smallest multiple which is common in this case. And then
you multiply 2 minus x by all the elements.
Well, so that gives you 3 plus 5 is 2 minus x. It's 2 minus x. Therefore, you have 3 plus 10 minus 5x is 2 minus x. So this is 13, that's 11, gives you 55, so that's going to be 4x. Therefore, x is 11 divided by 4. Okay. This makes sense. X is 11 over 4, which means x is 2 is not in this solution set. Suppose you had x is equal to 2, satisfying this expression. What can you say about this first term? What happens to this term at x is equal to 2?
Becomes 0.
What happens to the first term as x becomes 2?
3 over 0.
And what is that?
0.
Oh, you guys know.
See the domain, the domain.
You guys know how to divide by 0.
No, divide by 0 is infinity.
It's infinity.
I think so.
So mathematical science.
1. Should be a non-zero.
So remember, if x is 2, then 2 minus x will be 0. So after finding the LCM, it will be like you're multiplying these terms by 0. And we said that you multiply by a non-zero term. For example, 4 plus 5 divided by x minus 4 is x plus 1 divided by x minus 4. So here is a system with the no solution. I put it to you that this system does not have a solution in the real line. Well, suppose you didn't know that it has a solution. You did not know that it does not have a solution. Let us try to, follow the steps and see if we can get a solution. So the first step is to get the LCM of denominators, 1, x minus 4, and x minus 4. Well, the LCM in this case is just x minus 4. Then multiply each term by the LCM. Multiply each term by x minus 4. So we'll have 4 divided by 1 times x minus 4 plus 5 divided by x minus 4 times x minus 4 should be x plus 1 divided by x minus 4 times x minus 4. First, we have 4x minus 4 plus, so x minus 4, x minus 4.
So isn't it
4x minus 16.
Sure, yes, this is 16. Sorry about that. 16. And then how about the second term?
They cancel out, we have 5 left.
So
Plus 5.
is equal to
X plus 1.
x plus 1. And then, so this gives you, that gives you 4x. And then minus 16 plus 5, that's minus 11. It's the same as x plus 1. Okay. So then, like terms, so subtract x on both sides. So 4x minus x minus 11 is x minus x plus 1. Therefore, 3x. So 4x minus x is 3x. Minus 11, x minus x is 0. So you get 0 plus 1. Then now add x to both sides. Add 11 to both sides. So 3x minus 11 plus 11 is 1 plus 11. So that 3x is 12. And what does that mean? X is equal to 4. If you multiply both sides by a third. So what does this tell you? This tells you that x is equal to 4 will satisfy this system. But does it make mathematical sense? Does it make sense to say that x is equal to 4 will satisfy this system?
No,
Happen at x is equal to 4?
you'll get a 0.
And so what does that mean?
The system has no solution.
The system has no solution. And why? The reason is
Get an infinity.
the reason is you multiply by 0. Remember, if x is 4, then x minus 4 is 0. Is that okay?
Yeah.
X is 4, then 4 minus 4 is 0. So it means you multiply this expression by 0. But our rule, we insisted that the term used to multiply both sides must be non-zero. So this system will not have a solution. And in general.
Sorry, sir. I have a question.
Go ahead.
So I think you have been asking us this question. So a number divided by 0, what's the answer?
I don't know.
Because if the answer is from what I know, the answer is infinity, then the system is not that the system has no solution, but the system has an infinity of solutions.
I told you I do not know because we don't allow division by 0. There is nothing like dividing by 0. So there is no answer to a number divided by 0 because in the first place, you cannot divide by 0. Okay. Infinity is not a number. Infinity is just a symbol which we use to express a very large, quantity which we cannot express with the numbers that we have. Infinity is just a symbol. It is not a number. And to show you why infinity is not a number, maybe I need to show you why infinity is not a number. If I generalize this. Suppose infinity is a number, then you will say that 2 divided by 0, someone says is plus infinity. And if I have 10 divided by 0, that will also be plus infinity. If division by 0 was defined, okay? Hello?
Yes, yes.
Division by 0 is defined that you say 2 divided by 0 is infinity. Then anything divided by 0, so I put 10 divided by 0 is infinity. What does this mean? Let me multiply both sides by 0. So the first term we have 2 is equal to 0 times infinity. In the second term, we have 10 is equal to 0 times infinity. This is suppose infinity is a number. What do you know about multiplication by 0? What is 4 times 0? What is 10 times 0? What is 6 times 0?
0.
0.
But here you have now a number. You're saying this is a number. But then if I multiply 0 by this number, I'm getting 2, which is not 0. The same number, if I multiply it by 0, I get 10. So allowing infinity to be a number is not consistent with the real number system. I hope this makes it, I hope this gives you a hint why infinity is not a number. Infinity is not a number, it is just a symbol. Because when you include infinity in the real number system, then you have problems like this. You cannot have a number which if you multiply by 0 gives you a non-zero number. So that 0 times infinity is 2, and the same 0 times infinity is 10. What does this mean? This means that 2 is equal to 10. Is that possible? Doesn't that make sense? If you draw the number line, this is 0, this is 2, this is 10. These are two numbers. They are on different, in fact, the distance between them is 8. You can't expect them to be the same. So because of such inconsistencies, infinity is not a number. Someone should never cheat you that if you divide a number by anything by 0, you get infinity. It is not defined. It is not allowed. Can I make myself clear on this?
Yes, sir.
Or have I confused you?
Yes.
So from today, we have agreed that infinity is not a number, and there is nothing like division by 0. Because when you allow that, you will have such inconsistencies. When you say 2 is 10, someone can say that 1 is 5, 6 is 7, so that the whole real numbers are the same. What does it mean for all the real numbers to be the same? It means those of you who are born in the year 2000, they have the same age as those who are born in the year 2010. Essentially, all numbers are the same. So we don't want to be, caught in such kind of inconsistencies. So infinity is not a number. And there is nothing like division by 0. For those of you who will go to study analysis, which is what I do, you realize that there are different classes of infinity. In fact, these infinities, we have some infinities that are bigger than other infinities. Just like in this case, 2 is less than 10. So you expect that if you're dividing them by the same number, what you get by dividing 2 should be smaller than what you get by dividing 10. Okay? So if you go ahead and study analysis, you will see, this is called the Cantor set theory. You will see such kind of things. Infinity is not a number, it's just a symbol. I wanted to generalize an expression. So alpha plus n plus 1 divided by x minus n is x plus 1 divided by x minus n, where alpha is a real number, n is a real number, x is unknown. In general, on any equation of this form will not have a solution. In general, this will not have a solution. Or you simply say it's inconsistent, just like division by 0 is inconsistent. Later on, we'll be studying systems, linear systems involving more than one variables. So where you solve linear equation, maybe 4 variables, 3 variables, or n variables. We will also meet inconsistent systems. systems for which you cannot find a solution. And why does this system become inconsistent? Because when you try to solve this system, you will need to multiply by x minus n. So that means you will take x times alpha minus n plus 1 is x plus 1. Therefore, alpha x minus alpha n plus n plus 1 is n plus 1. And that means alpha x minus x is alpha n minus n. Therefore, x into alpha minus 1 is n into alpha minus 1, which means x is equal to n. And we know very well that at x is n, x minus n is 0. So what you did is to multiply both terms by a 0. Therefore, you get an inconsistency. Okay? Any questions on what we have learned today? Any questions, comments?
I have two quick questions for regarding the quiz.
Yes, regarding the quiz. Yes, that's cool. Quiz.
First, I want to know if the quiz will be on everything we have learned so far until today. And second, from what you have taught today,